In the last few videos, we've been trying to understand the two functions, f of x equals sine of x and f of x equals cos of x. And to try and understand these two functions, we would look at the we would imagine a circle of radius 1. So from here, from the origin to here is 1. Well, if the radius is 1, then the hypotenuse here is also 1. Well, we would imagine a point, this point here, moving around the circumference of this circle, and when we set up this scenario here, well, this here would be sine of x. So remember, x is like theta; it's moving around, it's increasing as this point moves around this circle. X, which is like the angle, which is like theta, is also moving around. Okay. Well, when we set up this scenario here, this here is a right angle triangle, and here you've got sine. Well, if you look at sine, if you look at sine x, okay, sine x equals this height here, which is h here, divided by the hypotenuse, which is 1. Now this thing here neatly becomes h. So rather than us trying to understand sine of x, we would try and understand h. So as this dot moves around this circle here, rather than trying to understand sine of x, we would try and understand the height. So as it moves around, we would just look at the height. So here the height is well, when it's at 90 degrees, the height is definitely 1 because the radius is 1. So if the distance from here to here is 1, then from here to here is also 1. And then as it moves around, you can see the height here is decreasing and decreasing and decreasing. And then over here it's on the negative side. Okay, so rather than us trying to understand sine of x, we would try and understand h, which is the height of this dot as it moves around. So we can use the same technique here. So when you look at this here, this is cos. Okay, so when you look at cos of x, when you look at cosine of x, cos of x equals the width here, let's call it w here, divided by the hypotenuse, which is 1. So this here neatly becomes w. So rather than us trying to understand cos of x here, we would understand the width. So rather than as this dot moves around the circumference of this circle here, rather than us trying to understand cos of x, we would try to understand the width of this dot here as it moves around. Okay, so when the angle is 0, when it's right here, then you can see that the width, when x here is 0, so it's just a straight line like this, the width is 1, and when it's at 90 degrees here, the width here is 0, and then when it's over here, then this is negative 1. So when x is 180, then the width here is really negative 1. Okay, it's exactly negative 1. So when it's let's say here, then the width would be this distance here, but on the negative side. So if you look at this here, my point is that when you try and understand sine of x, you are trying to understand the height as it moves around. When you're trying to understand cos of x, you are trying to understand the width here as the dot moves around. Okay, so looking at this here, hang on. So here you've got a let's say this is our unit circle. This is 1, this is negative 1, and then this is 1 here, and this is negative 1 on the x and y. Well, anyway, so here let's say when it's let's say when the angle here is 0. Okay, so it's just from here straight across. So the angle here is 0. But let's look at this point here. Well, when the angle is 0, then the height, which is sine, the height will be 0. So you see the red line here represents sine of x. The blue line here represents cos of x. And well, if you have this, let's say this point here is that when the angle is 0 here, the height here, the height here, which is, remember when you have this here, the height is sine. Okay, the height is sine. So the height is sine. The width here is cos. So just bear that in mind here. So when the angle is 0 here, the height is 0. That's why it's here. Remember, we are looking at sine because the height represents sine of sine. When is that? When it's here, the height is 0, but the width, which is cos here, is 1. Remember, this is 1 here. So it's here. So you can see it's here. And let's say when it's at let's say 45 here. Okay. When it's at 45 here, can you see the height will be the same as the width. So the height here is the same as the width. Okay. Well, let's have a look at when the angle here is 90. Okay. So the point is right here. Well, when the angle is 90, the height will be 1. So when it's at 90 here, the height will be 1. And remember, our height represents our sine of x, and the width here represents cos of x. Now, when it's at 90 degrees here, you can see that the height is 1. When it's at 90 degrees, the height is 1, but the width is 0. That's why our cos is 0. Okay, let's say it's let's say the point now is at 180. So this is 180 now. Okay, from here to here, 180. When it's at 180, which is here, you can see that the height, the up and down here, the height is 0. So when it's at 180, the height is 0, which means sine is 0. Okay, but the width is negative 1. The width from here to here is negative 1. That's why cos of x is negative 1. Okay, and let's say now it's the point is here. So we've done 270. Okay, 270. You see the height here is now, well, at 270 here, the height is negative 1. That's why it's negative 1 here. Okay, but the width is 0. That's why the cos of x here is 0. Look, 0 here, the 0 here. Okay, and 360, which is back to normal, back to the original. Then, well, the height will be, well, 360 here. The height will be 0, and the width is positive 1. So that's why it's like this, and then it will start the cycle again. So it goes round again. Well, anyway, so here your cos here. So the blue line here represents cos. The red line here represents sine. Okay.